Hello everyone, welcome to CS for All. So today we are going to talk about the very second problem of the AlgoMaster sheet, that is the kth largest element. And for this question, we need to understand the concept of priority queues. So we talked about priority queues in detail in the STL video. So if you haven't watched the STL video, the video will be available up in the I button here. Definitely check that out. So let's get started with the question.
Audio Jungle.
So now let's see what does the question states. So given an integer array, okay, so an integer array of numbers is given, and what do we have to find? We have to find the kth largest element in the array. So here what it is stated, the largest element in the sorted order. So the array must be in the sorted order in order to find the kth largest element. So let's go to the Miro board. So suppose we have this entire array. So 3, 2, 1, 5, 6, 4. Okay, so 3, 2, 1, 5, 6, 4. And what is the value of k? The value of k is 2. That is, we need to find the second largest element inside the array. So the easy method, the very easy method is actually sorting the array. Okay, so if we sort the array, what will we get? 1, 2, then we have 3, then we have 4, then we have 5, and then we have 6. So what will be the second largest element? It will be this one, right? The 5 will be the second largest element, so we can directly return that. So what will be the time complexity of this approach? The time complexity of this approach will be n log n, because we are sorting the elements, right? And then the accessing time will be big O of 1, right? So the total complexity will be O of big O of n log n plus big O of 1, right? So this will be big O of n log n time complexity. Now, can we reduce this time complexity? Yes, obviously we can reduce. So let's write the array again. 3, 2, 1, 5, 6, 4. So as we talked earlier about priority queue, so what is a priority queue? Basically, it is a kind of basket, and wherein you put the elements. So insertion time is what? Insertion time is big O of n. Okay, the insertion time of a priority queue is big O of n. So when you put in, what will be the elements in here? The elements will be ordered, right? First 6, then 5, then 4, then 3, then 2, then 1. It will act as a max heap. Now when we will pop the elements, what will come out first? 6 will come out first because it is a maximum element. So we will pop out 6. Then what will come out after 6? 5 will come out, right? So we will pop out 5, right? So how many times we will do this hippify? We will be doing the hippify for 2 times, because k is 2. We need the second largest element. So when we are hippifying 2 times, first 6 is coming out. So 6 is the first largest element, and then 5 is coming out. 5 is the second largest element. So this is the entire process. What will be the time complexity? Time complexity will be big O of n for insertion and big O of what? K log n. Big O of k log n, because we are doing the hippify for 2 times here, that is k times here. So this will be the exact time complexity, big O of n plus big O of k log n, right? So this will be the exact time complexity of the code. So I hope you understood the solution. Now let's write the code. So for the solution, we first need to make a priority queue. So let's make a priority queue. Again, I will be naming this a basket. So the data type will obviously be int. Let's name it basket, and what we will do, we will insert all the numbers from the vector into the priority queue. So let's say for let's give it auto number of nums. Okay, all the number and nums, I will be pushing them. So basket dot push number. Okay, so this entire block of code will take a big O of n, that is inserting into the priority queue. Now what we will do, we will heapify the elements until when? Until k becomes 0. So we can do it like this, while k minus minus, and let's say our answer will be stored in a answer variable or a resultant variable. So let's write resultant. Okay, let's write resultant equals to 0. So while k minus minus, resultant equals to basket at top. Okay, and then we do a basket dot pop. Fine, and then we will just return what? Resultant. Okay, so what are we doing? We are just hippifying the priority queue for how many times? For k times, so that the kth largest element is assigned to the resultant variable at the very end. So let's try running the code. Okay, let's try submitting the code. Okay, so it's done. So this entire code will take you a time complexity of big O of n plus k log n. So that is a superb time complexity. Yes, we can obviously use a better approach for this question. We can use quick select, but won't be talking about that here because we want to see the implementation of SQL functions. So I hope you enjoyed the video. If you like the video, drop a like, consider subscribing to the channel, sharing it with your friends. If you have any doubts or queries, you can comment down below, or you can directly reach out to us through LinkedIn. You can join our Telegram channel. We have daily discussion over there. So see you guys in the very next video. Till then, stay happy, stay healthy. Bye.
It's my life.